I might have to talk louder, although this seems quite good. So I'm Chris Hanlon, and I'm here to talk to you about how I requested password reset tokens, bypassed email encryption, intercepted the tokens, and exfiltrated my own confidential data. If you're planning to try this on machines, please do it on your own machines, because I don't want you going to jail. Before I get into the details, I'll cover a little bit about myself. I've been configuring and protecting servers since 1998, and yes, that does mean I took my first tech job when I was 16. I've been self-employed as an IT consultant since 2004. I have found a few vulnerabilities purely through diligence from my clients or my employers, depending on the situation. Not liking the sound. I'm not sure if it's the mic or not. Let's try it.
It's on, just turn that on.
Okay, let's see. This mic seems to be a little more consistent. We're going to stick with... Can we get a little more volume on it? Okay. Okay, I was at since 2000. So I found a Linux kernel vulnerability. That one was in file system module. It has been removed. After that, some proprietary software we used at the University of British Columbia, and then a couple Google Apps vulnerabilities where encryption was not being used properly. Fairly similar to what we're dealing with today. So every single one of these vulnerabilities had to do with email encryption. And the big factor, the core history of email encryption was that we had a draft concept of doing secure SMTP over TLS starting about 1998. By 2002, it became official with a request for comments 3207. And the spec's really interesting. It leaves a lot of ownership in whoever's sending the mail, be that a client machine or a mail server. So the mail servers have the choice to not send email if there's an encryption error, but in all of my tests, they were quite happy to send the password reset links without encryption if they ran into an error. So there's been a Google paper with researchers from Google and a few other universities involved in it, and they have talked about 4 ways that they knew about to intercept supposedly encrypted emails. And there's 2 that are tied to the TLS protocol. You could do strip TLS, and you could also, which means a man in the middle, which is really not a great term for it. It's really a machine in the middle, can send back an error message saying, sorry, we don't support TLS, and the mail server typically will send the email anyway. You then you can use a non-matching certificate. In my tests, I own the domain name, KelownaDivorceLawyer.com, that I was thinking about selling and maybe making some money on it. And I just used that certificate instead of the correct domain name, and everyone happily sent the email. Things haven't improved since the Google paper on the situation. There's also 2 ways to intercept emails using DNS attacks, and they might look like they're essentially the same thing, but in practice, it could be different name servers involved. So it's possible that number 3 will work in situations where number 4 won't, and the other way around. So large-scale man-in-the-middle attacks, at least with an active attacker who's intentionally intercepting the mail, have been going on for about as long as most people have been using TLS. Because it's only about 2014 where TLS started to become really popular on domain-to-domain email. And that's when we started to see the 2 biggest ISPs in Thailand both got hit where all their customers' mail, and in a lot of cases passwords, were being intercepted. And then one US wireless provider also got hit with a similar attack. These types of attacks aren't specific to SMTP. the middle attacks happening for AWS, and in that case, it was someone who managed to redirect a route and therefore redirect DNS, and they were able to intercept quite a few people's passwords and then steal about $20 million worth of cryptocurrency. When it comes to TLS, Chris Kubeka, who is another speaker here, did a report back in last December of about 11,000 different hosts across the internet that appeared to be performing stripped TLS attacks. Over 3,000 of them were here in the US, and people might wonder why you'd want to do this. And if we look to the Google paper for advice, a big part of that appears to be people who have configured firewalls to scan encrypted email. And one of the challenges with that is a lot of the documentation for the firewalls doesn't tell people, hey, when you turn on the scanning encrypted email feature, if you don't configure it perfectly, which can be impossible to do in some cases, you will disable encryption on all incoming emails. So it could also be someone spying. There's definitely evidence that there's spying going on with that. And it could be someone like me who's trying to intercept password reset links, or someone a little more malicious. The ultimate phishing attack would be to take legitimate emails and inject malicious links, where you could phone the person up and ask them, hey, did you send me this money transfer? Oh yeah, I sent it to you. You click the link, it takes you to a fake site, and then they steal your banking passwords and steal your money. If they were really smart, they would probably also steal the transfer at the same time. So, what do you need to launch an attack like this? I used to say you needed to control a router, but really, if you control a switch that the router is connected to, there's often ways to intercept the same traffic. Also, if you control a DNS server or an email server, you can do the same thing. And you also need something that'll intercept email. Now, I'm guessing there's at least one red teamer in the audience. Are there any red teamers in the audience? Okay. Now, I'm thinking any red teamers that were trying to do this, they wouldn't use Exum. It makes for nice, easy examples, but they'd probably use something like a script, like maybe a proxy in Python. That's where we start getting into more advanced attacks. They also, like the Amazon attack, they can do a BGP, which is a routing protocol to redirect emails to, or any traffic, to a different router. I have personally also on my own networks used ARP cache poisoning attacks, which is fairly similar to controlling the switch. So I did a quick trace route from the Cisco Meraki mail servers, which are actually on AWS, and the route it would take to get to this hotel. And most people don't think of Atlanta as en route from Seattle to Vegas, but there's some very fast network links that go east to west, and that's why it goes. Now, if you're looking at that map, some people might notice that it's following interstates. I'm betting that the real network routes don't follow interstates, but I can't guarantee that. Most cases, the interception would happen at several hosts that are close to Seattle, or the Atlanta portion, or the San Diego detour. And that San Diego one, I'm a little uncertain. Different geographic databases said that host was in different places, so it could be in a lot of different places. Oh, those BGP shortcuts. Those ones are kind of like if there was a router in Idaho that was saying, send your network traffic here, you don't need to go to Atlanta, it'll be faster, it'll be cheaper, you won't use as much gas, not that routers use gas, and your traffic, they then intercept that traffic that was probably supposed to go to Las Vegas, and that's where they perform the attack, even though they're normally not en route between those hosts. Before I got into my test attacks, I made sure that my mail server was configured correctly. A big part of this was that I figured some service providers might be smart enough to require encryption on when emailing domains that they'd already sent encrypted email to. So we can see I've got a valid TLS certificate. I've got the name matches the host name that we're sending to. And everything meets the best practices for receiving email. Then I simulated an upstream router. In this case, it's acting as an upstream router. It's a Ubuntu Linux box. Most routers aren't running Ubuntu Linux, but I imagine an attacker would probably want to redirect the traffic when they're intercepting it to another machine rather than launching the actual attack right on the router. So we install XM4 on the upstream router. I had to modify 3 lines of the config file. I set it to work in internet mode. That internet mode just means, hey, it needs to accept incoming email. I set it to accept email for all host names. I think a real attacker would want to do that, but you could theoretically just accept email for the destination host name. And I told it to listen on all interfaces. The 0.0.0.0, it effectively means no matter what interface I take over, it will listen. After saving those changes, I had to do 1 command to activate the changes, 1 ifconfig command to take over the other IP address, and I had to restart XM. Before requesting the links, I ran another test using check TLS. And we can see this server does not support TLS. It doesn't have a valid certificate, really doesn't meet modern security standards. And I would hope that people sending password reset links would not send them. So I went and requested some password reset links. I started with Cisco Meraki firewalls, because I thought those would be interesting. This is an out on the internet-based attack, nowhere near your network, and we're able to get into the control panel for the Cisco Meraki firewall. We start forwarding ports into the network. From there, we're also able to disable all the filtering features on the firewall. So if you wanted to stop other attacks, that's getting enabled. We're able, if the person uses a Microsoft account, to reset their Windows password. We're also able to reset their LogMeIn password. And we got into their Dropbox account, their OneDrive account, their Amazon AWS and Oracle Cloud accounts. We managed to break into my medical records, which could be kind of interesting. All it showed in there was that I went for a sleep study, that I snored really loud, and that I was not breathing properly when I was sleeping. But for someone else, it could show something worse. It could show maybe that it could be their STD test. It might be something you could blackmail someone on. Similarly, we tried a Google Nest security camera because I had one sitting in my office. We reset the password for the Google Nest security camera. I had the audio turned off because I didn't really want to record everything I said in my office and the music that I played in my office. But we were able to remotely turn on that audio. And I also share my office with a barber shop, and part of why I found out about this was that one of the cameras is in the barber, and he really didn't want his conversations with his customers being recorded. So you can imagine, I don't know if anyone's ever had a private conversation with their barber or their hairstylist. I think it happens pretty often, and the barber wouldn't be getting any kind of notification until they tried to use their password and went, hey, my password doesn't work. So there were quite a few more things. One of them that was interesting was BitLocker now prompts to upload your BitLocker key to OneDrive. So we were able to remotely reset the person's password. We could either log on to the physical BitLocker encrypted machine or download the key and get into their external hard drives. There's a little more of a list there. The Skype ones can be interesting for impersonation. Dropbox and OneDrive, those ones, they often contain a lot of confidential data. When we got over to the online backups, you can see 3 major online backup companies there, from Carbonite to OneDrive, from Carbonite to Mozy to Backblaze. Those ones were awesome because we had our mail client configured on the test machine. So we were able to start downloading people's saved web passwords and saved email passwords out of the backup. You might think, well, you were getting into this via email. Why would I care? Let's say your man-in-the-middle attack is close to the backup provider's server rather than close to the destination mail server. The backup's really nice because now you can go into their main email account and start resetting all their other passwords. I did a bit of a graph. I'd love to have someone who's good at graphing help me out with this graph. But the core idea is pretty much whatever we get into. If we get into a router, we can get into more. That we reset hosting account passwords, at which point we could then change DNS records to intercept more password reset links. We broke into, from one router, we were able to break into other routers because we got into the Cisco Meraki routers. It kept going on and on and on and on. What do I have? So when I had the reception server running, it actually got even more interesting. A lot of the service providers were sending us usernames. So we didn't have to know the usernames we wanted to intercept passwords for. We just watched the email coming in, and we found out what accounts different users whose email goes over that server get. So we found out that adam@pandozy.ca has a Windows account. So we can reset that. We don't know what Microsoft features they're using, but there's an awful lot of them that store data there. Then the LinkedIn one was fun because LinkedIn actually recommended that my sample victim account add me as a connection. And then also my friend Adam Bennett, who was helping me out with the work. So I'm guessing it was working based on IP ranges and maybe occupations because that Gordon Baldwin, I don't know who that is, but they're in our region and they work in the same general field. From my perspective, a single compromised host shouldn't expose hundreds of accounts. And it doesn't seem to matter where that host is. There's almost always password reset links traveling over it or other ways to get an email to reset passwords. After US CERT said, we think your findings are valid, but this is not the type of vulnerability that we will coordinate responses to. I sent them a list of additional CWEs that it appeared to violate. Most of these CWEs are on current OWASP top 10s or previous OWASP top 10s. I would say that it doesn't seem like the sending mail server is authenticating who they send to. They're happy to send to whoever it gets to. That seems to meet CWE 287. It also seems to meet CWE 291. I would say this qualifies as missing encryption on sensitive data. I consider my password reset tokens pretty sensitive, especially when I didn't ask for them. And I would say the same thing about usernames. It's generally not something you want to post in public. And that also fits in with clear text transmission of sensitive information. I would also consider this a weak password recovery mechanism. I mean, they don't care who they send the link to. It's purely whatever they're told either by DNS and whatever IP address it ends up at. So there were some vendors that were pretty awesome. There's a shout out for Apple on this one. Apple automatically did push notifications on phones and tablets to let people know their password was being reset. Even if the phone had been offline for weeks, it would still send the password reset email at random timing. This seems to be protecting from you let someone on your device for a couple minutes, then they reset your iCloud password and take your data from somewhere else. They're the only people that use that approach to protect people. And I would really like to see everyone use that approach. If you've got an active session, either on a desktop, a laptop, a tablet, it doesn't really matter. Why not let the user know someone's trying to reset their password? Microsoft Azure, they had mandatory two-factor authentication. If you try to reset a password on a system that doesn't, on an account that doesn't have two-factor enabled, it will just refuse. It says, sorry, we can't reset the password on this account. Talk to your system administrator. Now, that was the only admin account on there, so I didn't really have another option. I'm getting a little low on time. Gmail had some pretty awesome options too. They asked when the account was created. They also asked what was the last password you remember. And if you got those wrong, they would say, you're going to have to talk to support. We'll get back to you in about 3 days. Now, what's really interesting about the Gmail approach, if you try this from an IP address or a machine that's already logged into the account, they actually let you reset pretty easily. They only enforce the extra questions if you're on a new machine and a new IP address. And I think that's a pretty cool balance between, usability and security. So, what else can people do to defend their applications? We've covered a couple of them already, like alerting the signed-in users and asking tough questions. I would consider two-factor authentication on password resets. Users can also use that to defend themselves, but not all the time. We've got LogMeIn over here. You have the app set up beautifully to alert you on your phone that you're trying to log in, and you just hit get the token via email. And we intercepted the two-factor token the exact same way that we intercepted the password reset link. That is not specific to LogMeIn. That weakness impacted other vendors as well. So I've got a few people to thank. My mentor, John Seymour. He was super helpful in getting this talk ready. Adam Bennett, who works with me at my office. Jerry Dyson. I'll be quite honest. I tracked him down because he had a bunch of CVEs related to man-in-the-middle attacks, and some vendors were actually saying back to me, we'll consider this if you resubmit it without a man-in-the-middle attack, which there's been quite a few major man-in-the-middle attacks like Poodle, and those vendors that don't accept man-in-the-middle attacks as a legitimate vulnerability are missing out on real vulnerabilities. And Chris Kubeka, who's speaking here, and it says stop now. Does anyone have any questions? Seeing none, I'm also going to be speaking at DEF CON. It's quite similar to this. It'll be in the Packet Hacking Village on Friday, but it's much more applied. So if you were wanting to see some real examples where there were some actual break-ins, you might want to come to the Packet Hacking Village at 5 o'clock on Friday.